Good evening, everyone. Welcome to today's vacuum transport seminar. This is already the third edition of this semester. And we're very happy to welcome everyone tonight and also to have those two interesting talks today. We will start off with Anna Garcia. She's a master student in management at the Technical University of Munich. And afterwards, she will talk about the Hyperloop technology entry strategies for the European market. And then we follow with three people presenting. They're all from Poland. So we have Rafał Rumin, we have Katarzyna Kdowska and Olena Strioniwska. They're all researchers and assistant professors at the university in Krakow. So we're very happy to welcome all of you tonight. And to start off, I will hand over to Elias in a second. But first, I would like to remind everyone again that we're using this tool called slido.com to collect all the questions that you may have. So I will put all the details into the chat in a second. And so it's slido.com and the event code is VAC Transport Seminar. And please feel free to write down all your questions in that tool. And after every presentation, we will go through the questions and ask questions to our presenters. So I wish lots of fun with the presentations. And I would like to hand over to Elias now for a quick introduction of Anna. Thank you.
All right. Hello, everyone. Before I introduce Anna, I take the moment just briefly to introduce myself real quick, because for some reasons, this is the first time I'm here in the vacuum transport seminar. And from now on, we'll hear more times. Yeah, I'm the team lead of TUM Hyperloop. I study mechanical engineering and now automotive technology. So I'm super interested in future mobility in general, and also super motivated to be able to shape these in terms of the Hyperloop. Okay, now let's talk about our first talk. Here I just want to highlight again how important it is for basically any product, but especially for the Hyperloop, to have a thought through market entry strategy. Because with these modern innovations, this is definitely a key. I know we talk a lot about technical stuff here. This is also super important. And yeah, Anna has been a team member in our team for several years, actually. We're super happy to have her, not only for the great output she is going to present you today for the research environment, but also for the knowledge she provided for us in the team to use. With that being said, I'm looking forward to the talk, Anna, even though I know some stuff already. The stage is yours.
Great, thank you, Elias. Thanks for the introduction, and also thanks for the warm welcome and the invitation to present here. Let me know if at some point my internet is shaky, because I might have some problem connections and I can just connect to another network. But yeah, let's get started. So what I'm going to talk today is about as we've already mentioned, the entry strategies for the European market. This was a research performed in the Technical University of Munich for the TUM Hyperloop team, and also for the chair of strategy and organization. And yes, so the idea for this complete research is that it can be directly applied for the Hyperloop technologies, but also can be somehow tailored for other new modes of transport that are entering the European market. And how it all started, inside the team, we're doing different research, not only in the technical aspect, but also in the market aspect. And for example, when we are analyzing one route, Munich to Berlin, we were trying to understand how it is connected right now. So we can see that it can be connected by car, and it's around 7 hours. It has a carbon footprint that is high compared to, for example, the train, as we will see soon, but it has a higher flexibility, because it means that we can stop anytime we want. You can leave and arrive in your expected schedule. And it's not so expensive as compared to other modes of transport. For example, in the train, when we continue with this different route, it's around 4 hours, The carbon footprint is a bit lower than by car, and it has less flexibility, but it's also a bit more expensive than the car. Let's talk about the airplane, which is around 3.5 hours. But we can see that there has a greater carbon footprint. There's also way less flexibility because you also have to consider the strict schedules and the time to get to the airport and the time to go through the airport through security checks and so on. So finally, it also ends up being more expensive. What would happen if we had this Hyperloop concept that we are here to all talking about and developing? It would be less than an hour trip with the minimal carbon footprint and this moderate flexibility with like a moderate price as well. But this all sounds great. This all sounds like the dream, right? But what does this mean in terms of the impact that it can have? Or actually, what are the different steps that need to be taken in order to make this dream a reality? We know that this is not something that happens from one day to the other. We know that this is a complete process and it's all about progress and collaborations. And this is what I tried to discover in this research. And I will, talk a little bit more about it. To be able to understand what are the steps needed to introduce a new mode of transport, specifically a Hyperloop into Europe, I tried to answer the 4 main questions that would take me to the process of the strategy drafting. The first one was to understand what's the state of the Hyperloop in Europe. So what is the research? What are the companies? What are the research organizations? And how is that translated into the technological developments and advances? The second question that we proposed was, what are the transportation trends? The idea was to see how is the transportation industry going towards the future, and then understanding this, how can the Hyperloop tailor their own service or value proposition to be able to fit into this future transportation trends. The third one was to understand exactly this, if there is a fit for this new mode of transport. And finally, we were able to also draft a strategy by answering the question of which was a successful entry strategy. So these questions are targeted by, first of all, a literature research, which puts together all the different, different literature that is out there, not only the scientific articles, but there are also, we also found different research, such as feasibility studies and thesis, of course. Then trend analysis. This was done by also different type of research on the actual status of the mobility and in the transportation industry, and then trying to understand the different aspects of where it's going towards. Afterwards, 13 interviews were conducted to experts within the mobility innovation sector. So in this aspect, we tried to not target only Hyperloop companies and research institutions, but also different companies that are dealing with mobility innovation. And finally, there was also, as I said, the strategy drafting. So let's see how this looks like after I've explained to you a little bit of how this was all performed. So the analyzed sources that impact the European Hyperloop landscape were around 25. So 25 that have the 4 main different aspects. So one of them is technology, market analysis, logistics, and financials. And I am also happy to share later if someone wants to see the sources. I have a full list with the downloaded sources, because what helped us here was to come up with a homologous definition in this 4 different aspects. So for example, what actually is the Hyperloop technology? Because we know that the developers all have similar propositions, but they sometimes define different things. And by analyzing all of these articles and these reports, it was possible to come up with one, not standard definition, but a better understanding of what are the actual definitions out there. And same with the market analysis, because different research proposals come up with also very different understanding of, okay, what is the best market for a Hyperloop? Also, which are the best routes and how much would it cost? So we believe that by having an understanding of all of this, we were able to make a better definition or understanding. We also wanted to see which were the main companies that were taking action in Europe regarding the Hyperloop. And the main one, sorry, I just saw something in the chat, all good. These are the main ones, and we can see that they are already developing testing facilities, as well as as well as the funding that they have. This funding is extracted from Crunchbase, which is a platform that tells us different information of different companies. And of course, also the other research organizations and initiatives such as TUM Hyperloop. And with this understanding, it was possible to see that, that the European landscape regarding the Hyperloop is very developed. And there's also a lot of willingness into bringing this into our reality by also all the different investment and also the different research projects that have been pushed forward by the European Union. But let's now look at the trends. We were able to identify trends in 3 different classifications, or in 3 different aspects. So in the economic area, the social, and also the technological. And this, as I said, would help us to understand how to create a strategy that suits the path and the future of the transportation industry. So let's talk about the economic trends. One of them talks about the share economy that is giving rise to also shared mobility. And we can see it now. We can see how this is taking shape in a lot of car sharing services, and how more and more people are not so much willing to own a car, but rather to share it. Also, then on the economic, we see the intermodality through mobility as a service. And this is something that's already being developed, that they're trying to integrate different types of modes of transport into one same platform, where you can have the flexibility to decide where and how you want to travel. If you want to have a combination of 2 different modes of transport. So for example, in just one app, you can just finally decide, if I want to get from point A to point B, maybe I will have to use a bicycle, and then I will have to use a train, but everything is already integrated into one same service. Then it was also found that there has not been enough transportation funding in the past years, because there are a lot of lacking projects that have been tried, like it has been tried to be solved with the European funding, and also with the existing state or country government, but somehow it ends up not being enough to sustain all the projects and in the speed that the project would be wished for. Now let's move on to the societal. When we talk about the fragmentation in the transportation market, we understand that there's different modes of transport with a lot of different companies that are trying to enter the same market. And this is where it's important to understand how to deal with the different stakeholders. Then the demographics are highly affecting transportation patterns. This means that in different areas, some people are being older, or like the demographic is becoming towards an older generation, but also in some areas there's been a lot of flow of migration, and all of these migration flows are also affecting how we will transport in the future, and also what our needs will be towards the future. When we're talking about if we want to live in another city, the city where we work. And the third one, for the societal, it talks about the sustainable consumption culture, which is this this willingness to actually sometimes even pay more money to be able to use a sustainable mode of transport. The technological ones are more in the direction of the digitalization of mobility and the new mobility concepts. And this is something that will also shape how the future generations perceive new transportation modes, and also how new transportation modes have to be approached to the public, because there has been way more introduction of the digitalization into the transportation sector. And how does this look like when we talk about the strategy, or at least the insights? After doing the different research, but also doing the different interviews, we were able to come to 3 main aspects. So let me start with the customers. The customers talks about how, as you know, the Hyperloop can be developed for two main customers, for cargo, but also for passengers. And although cargo, the idea is that it's the first, as it has been seen, the cargo would be the first use case. It's important that since the beginning, it is also developed with the passengers in mind, because this this usage of the Hyperloop to be able to supply the demand for cargo and passengers is what's going to make it more profitable. But what's also important is that the value proposition that is developed since the beginning is something that fits into both of these aspects. And one research that was done at the Technical University of Munich was the technology acceptance model, but now with the research for the Hyperloop. And as we can see, it's going to be really important for the customers to be willing to use a technology that they can perceive a usefulness, that they can also perceive that it's easy to use, that they can also understand that they can trust it because of the safety that comes behind it, and also, of course, their own societal and personal behaviors. But this is also a very interesting research. I recommend it. Technology acceptance model for Hyperloop by Islam, and it really brings us more understanding of what are the things that we have to focus while we're developing the technology, but also while we're developing the value proposition to address customers. Now let's go towards the other two aspects that were the main takeaways from the interviews and from the research. When we talk about the main challenges, we know that the acceptance is something big. We have to understand that the passengers and the public will maybe at first have a lot of skepticism towards a new technology that is also foreign to them. So this is something that has to be really closely targeted on the value proposition and also on the whole timeline of the project. Regulations are also a big issue, as we all know, and I know that is something that every Hyperloop developer is already working towards, but this is something that most of the interviews that were asked about the regulations were the most concerned about, because it could be a main barrier if the regulations are not done with enough understanding of the technology, but also of what the public and the whole ecosystem around the technology needs. Then we have the aspect of sustainability and technology development. We know that developing technology can sometimes not be as green as we would wish, but this is something that also has to be communicated. And I will talk about it in the next step, but of course we also need to know how to communicate the sustainability of the Hyperloop, because we do say that it's lower emissions, but we also have to consider the complete life cycle of the construction of the infrastructure and so on. Of course, the competition and the stakeholders is something that has to be taken into account, because there's always a lot of people that are being interested in the development, and also how are we going to be able to put all the players into action here. And finally, when we talk about the challenges, about the profitability, scalability, and funding, it's going to be pretty, it already is pretty interesting to communicate how the Hyperloop would be profitable when it is not something that might have returns on the next day, as maybe some companies will have. This is something that is more on a long-term vision, and it will be, it is already something that needs to be communicated with a very special target and also with very special stakeholders. And now when we talk about the insights when it comes to the stakeholders, we have also understood that the main stakeholders are the university and the academia, also the Hyperloop developers and all the other modes of transport that are playing a role here, the media, the financing institution, and the government and regulators. So as I mentioned, we used all the previous steps, the trend analysis, the literature review, and then the insights from the interview to create a strategy. And the strategy pretty much puts together all what I have been mentioning right now to be able to make sure that there's a fit. I here just summarized it because of the interest of time, but I, of course, anyone can reach out to me, and I'm happy to provide with the research and also to explain more about the findings. So when it comes about the Hyperloop development, it's really important that the Hyperloop developers and the researcher as well have a really clear and transparent roadmap, because without this roadmap, it will not be something that people and the public will trust. And it's also something that it might not be so well perceived by, for example, the financing institutions. It's also important that while developing the Hyperloop, we're not only having a look at the technology, but we're also having a look at the business. And this is something that is already being done by most of the companies and also the research institutions and the organizations. But I think it's something that it's really worth to note that if the technology works, but there's not a business plan for it, then there's high chances of failure. And for example, something that can and has been very much talked about is the Transrapid in Germany. But we know that this parallel development is something that will ensure success. Then when we talk about the acceptance building, as I've been mentioning a lot, it's about the value proposition, that it's very important that we take into consideration always who the technology is developed for, and that we're always very careful on making sure that what the benefits are and what the what it's going to bring for society is really well communicated, so that they always end up seeing. Of course, they will see the risks, but that they also end up seeing what the benefits are, and that will earn the trust and the support. We also wanted to make sure that the use cases have been really important for the development of previous technologies. So in this, I mean, if people and the public understand that the technology has use cases we can exemplify. So for example, maybe demonstrating the technology in a smaller use case, such as a track from a city center to an airport, because we know that that is not the final use case of the Hyperloop. But if they see the benefit in something smaller, then they will be less skeptical to invest and to put their trust into the full length of the project. And finally, stakeholder integration is also a big one, because it's important to also note that we're not playing just with a few stakeholders, as you saw in the previous slide. There are a lot of people interested that will have to be involved and will have to be managed in order to create a successful entry of the Hyperloop into Europe. So something that has already been done, and I think it's something that should continue to be implemented, is a development hub, because this is a place where all stakeholders can be managed at the same time. So this is where all the universities can come together. This is also where the press and the media can also understand the roadmap, and of course also the competition and the investors, for example. Regulations are also something clear, that they have to be the regulators and the politicians and the government and everyone that has a role to play in the regulations is involved since early on of the development. And of course, noting that there's a lot of, as I said, in the trends, for example, mobility as a service. It's important that since now we try to understand how the Hyperloop will be connected to other modes of transport and how it will be integrated into the existing transport modes. And yeah, as I said, I'm really happy to elaborate if there are questions, and also to send out the research. But for now, this is it, and I'm happy, to hear the questions. And again, thank you for the invitation.
Thank you so much, Anna. It was very interesting. Thank you for the insights into your work that you're doing, or that you have done so far. I would like to head over to the questions of Slido, and it would be nice to go through them. So the first question is, so somebody's asking, how far has been the exchange with the German government about the investments and fundings for the Hyperloop concept proposed by TU Munich or TUM Hyperloop?
For that, I can say that the government, or at least the Bavarian government, is very interested, and they're also supporting the research. This is something that it shows that there is interest into improving the transportation system, and there's also a lot of interest from not only just the existing government, but overall the politicians and also the university, and also a lot of companies that have been really supporting since the beginning that we started with this project. So I mean, I think their support, I mean, they know 100%, I mean, they know of our plans, they know of our prototype, they know what we are developing, and we hope that we can, yeah, continue using these strategies to keep them on board.
That sounds very good. That sounds very nice. So then the next question is related to the list of organizations who build testing infrastructures. So somebody's asking or wondering if Eurotube is also part of this list.
Yeah, so in this main slide that I had, I only put the companies, but we also have the different organizations and student teams, such as Hyperloop. We also mentioned Delft, and I'm also happy to share this with you. We also have the different Swiss student teams, and of course, we even interviewed Eurotube. So yeah, happy to share. But yes, ours is also one of the the key players in the organization side.
All right, then we have the third and last question, and somebody's wondering, did you only include venture capital for the funding because HEART just got 15 million euros by the European Union?
This is I think this was taken some months ago, this list, and it's the official one from TechCrunch, and I think that one only talks about exactly venture capital. I don't think that it includes different type of governmental support and funds. Yeah, but that's also something important and interesting to consider, as you said, because it does add up to the total funds that they have to realize their project.
All right, that sounds good. So again, huge thank you very much for your presentation and sharing your insights. It was very interesting. Yes, so I mean, thank you from all our organizing parties for your talk. And yes, I would like to welcome our next speakers, our friends from Poland. So again, this is it's Rafał Rumin, Olena Striuniwska, and Katarzyna Gdowska. And I would like to ask you to share your screen. And so welcome to the Vacuum Transport Seminar. And yes, I would quickly like to hand over to Daniel to give short introduction. Yes, thank you very much.
Thank you very much, Natalie, for the short introduction. Personally, I wanted to thank Olena. We had the opportunity to meet during the European Hyperloop Week, during a short coffee, and after proposing the Vacuum Transport Seminar, she was also always really responsive and wanting to collaborate, so a huge thanks for this. I would like to introduce them shortly and on what they have been doing so far in the University of Science and Technology of Krakow. And the main talk for today, as you can see it on the screen, would be about a concept of integration of a Vactrain underground station with the Solidarity Transport Hub in Poland. Katarzyna Gdowska received a PhD in industrial engineering. She is an expert in the field of operations, research, and management sciences. And then in between 2007 and 2018, she did a postdoc in transportation models in the era of Internet of Things. Now she's currently working as a research assistant professor at the Faculty of Management and the University of Science and Technology. About Olena Striuniwska, she received a PhD in industrial engineering at the Faculty of Management of the University of Science and Technology of Krakow, and she specialized in factory layout and planning for manufacturing companies, research in the development and implementation of vacuum railway technologies. Currently, she's working as a researcher and assistant professor at the University of Krakow. And finally, Rafał Rumin. His main area of research is related to the energy, logistics, and transport and mechatronic systems. Talking about the research projects which are ongoing now, he's been focused on the analysis of the possibilities of developing and implementing and the vacuum rival technology Hyperloop in Poland. And I'm really happy that they took the step forward to participate in the seminars. And without further dilation, I would leave the floor to you guys.
Okay, thank you very much for the invitation. I'm very glad to be part of the seminar, and we will start our presentation from Katarzyna Gdowska, and then we will share the screen to show you some our results with our models, and then will be some time to ask some questions. Please, Katarzyna, start the presentation.
Okay, thank you very much. Is the presentation visible? Okay, thank you. So we are a part of a Hyperloop ecosystem in Europe. After conducting a project on Hyperloop technology and possibilities of its implementation in Poland, this is why and where our work is linked to the presentation of Anna, because they also conduct some big perspective studies of Hyperloop possibilities and Hyperloop situation in Europe. And we know that this kind of analyses are needed to properly prepare implementation of Hyperloop technology in Europe. So today's speakers are Katarzyna Gdowska, Olena Strychniowska, and Rafał Rumin from University of Science and Technology in Kraków, Poland. We are from Kraków, big city in southern Poland, and we represent AGH University of Science and Technology, the oldest technical school in Kraków and the second old technical high school university in Poland. As the agenda of our presentation is first introduction to big game changers in the landscape of transportation in Poland, Solidarity Transportation Hub and Vacuum Railway Technologies, which both are so far at the stage of research and conceptual phase. Then we move to the presentation of results of our Hyperloop project, especially Vactrain underground station. We will show you concept and design, and then some results of simulation of this underground station. And certainly we will summarize it with some remarks. So let's start. What is the Solidarity Transportation Hub? It's a project. It's a project of new, modern, and huge transportation hub in Poland, which is supposed to be located here, as you can see in the slide, somewhere in the middle of nowhere, actually, but in the middle, mostly, let's say that it's in the middle between Warsaw and Łódź. Why? Because after research, it was found out that the biggest passenger flows are between these two cities. So it was natural to place big intermodal, multimodal transportation hub with huge airport somewhere there. And all the research and preparation phases place this huge airport with a big intermodal hub there in so-called Gmina Baranów. The whole project is supposed to be finished by the year 2050. And it is supposed to change the landscape of transportation in Poland, definitely, but also in Europe. And as it is still in conceptual phase, it is natural to place there another project, another ideas, which are also in conceptual phase, which are Hyperloop in Poland, which is a part of Euroloop network. Nowadays, we have only a visualization of several projects done by architects for Solidarity Transportation Hub. One of them is a concept prepared by Chapman and Taylor. And what is important about it, it is implicitly said there that it is Hyperloop friendly. So they foresee placing there, combining Hyperloop technology with this huge transportation hub. Another project done by Foster and Partners is the concept of modular structure of this huge transportation hub. So there is also possibility to place in some modules Hyperloop technology. So there is a potential of combining Hyperloop technology with this huge investigation. The modular structure gives us possibility to place our station underground, overground, on the ground, and conduct some experiments with different possibilities without special costs, because it is all made on the simulations, mostly computer simulations. Here in the slide, you can see what routes of Hyperloop network are expected and considered in Poland. And as you can see, CPK, which is Solidarity Transportation Hub, is considered in two of them. And here you can see that there are different approaches to these routes, underground, ground or overground, because here this green part in the middle of this map is a protected area, so-called Nature 2000. And it must be either protected or, well, we can go under it, or we need to bypass it. Let's move further. So far, there is no master plan for this Solidarity Transportation Hub, so we don't know how it will be placed in that Gmina Baranów, and it is our forecast here that here in this Hyperloop line, we can put station here, so it is close enough to this big airport and can be real part of it. Vacuum technology in Poland, it was also one huge project financed by the European funds, and it was the The title of the project was Potential for the Development and Implementation of Vacuum Railway Technology in Poland in the social, technical, economic and legal context. So we are part of this research. The research was conducted for 17 months, and in these days finally was accepted. The results were accepted, so the project is closed. And the consortium was comprised by 3 big partners: ministry, 1 private university, and 2 the biggest technical universities in Poland. And here we are. There are also HEH University of Science and Technology. As a part of our research is the design of Vactrain underground station, which is supposed to be placed in the Solidarity Transportation Hub. And we considered the underground route, so our station is also placed underground because there we have much more flexibility in designing. The project was done in ArchiCAD program, and there we can observe 2-dimension models, 3-dimension models. The station is 4-layer object, and the first level is on the ground and place all the entrance, parking lines, and so on. The second level is at the level of -5 meters, and it places some infrastructure. Then we go deeper. Okay, here we are still in the second level, 5 meters below the surface. And here we have check-ins, security check, and so on. And then deeper, we can go to the third station, where we have typical aerial infrastructure. It's on the level of -13 meters below the surface. And here is the visualization of this level. And finally, we reach the 4th level, and we are finally at the platforms, and we can get in capsules of low pressure trains. Here you can see slides of this station, and finally we can show you how it could look like from the outside. And as you can see, the line, the tube here goes underground. More details here about this design will be presented now by Dr. Strychniowska. So Olena, the floor is yours.
Okay. I share screen. One moment. Can you see my ecran?
Not yet.
Okay, one moment.
Is it visible now?
Yes. One moment, please.
And now?
Yes, we can see your screen.
Yes. Okay. Okay. I want to introduce the Hyperloop model, which is a representation of an underground hub. I used the Archicad program, and the model consists of 2D plans with the possibility of transition of the sections of facades to 3D. I see these options. For example, I see on the horizontal section, and you can see all information of Hyperloop. Okay, the 2D plan has 4 different levels. The first level here, can you see, is on the ground level. The second one is 5 meters below ground level. The third one is 14 meters below the ground level. And the last one is 20 meters below ground level. On the first level, there is the entrance to the Hyperloop. Yes, and which consists of escalators and elevators, so that you can go to the lower floor. A parking lot for cars and bicycle has been designed near the entrance to the Hyperloop also. The parking and bicycle. Okay, also on both sides of the entrance, lifts for disabled have been designed. Okay, on the second floor, there are cache desks, gates, toilets, administrative and service rooms, and medical center, a lost property office, luggage office, and boutiques. And we can go down to the lower floor. The next level can be see also boutiques, city cars room, utility room, disposal room, office, maybe break room, breaks room, VIP rooms, and room for disabled people. Safety gates also, and exit zone, zone for entering escalators, reaching the short level and last level. And this last level, on the last level of the model, there are platforms to enter or leave the Hyperloop capsule. And we can see 3D model. Capsules, and we can go to rooms and we can see all model of Hyperloops. This model have so many objects in ArchiCAD and objects individual objects also. This is all transport system for Hyperloop, and this system I see now. Can you see capsules and people in the capsule? and all transport system. Okay, thank you for your attention, and I give the floor Dr. Rafał Rumin.
Okay, Dr. Gdowska, please share the screen with the presentation, and I will start to talk about why we are showing you ArchiCAD design, why we want to show you all details, mainly because those that work we done here have not only the aim to show the visualization how it could looks like. We want to do it something more, and we did something more, because we prepare simulations based on this conceptual model. Next slide, please. Based on this conceptual model, which was done by Dr. Stawnicka, we create a simulator using simulator like FlexSim software. We create dedicated station system which can be supported by the passenger flows, by the capsule flows. Whole system can be included to those simulations, and we will share you some basic data about our model to give you some information what we can provide as a team to, for example, your models in future, if you would like to join or invite us to operation. Here you can see there is some part of model. This is the lowest and the middle low level of the station. Here you can see there is something like a little simplification for our passenger flow, but on the right side there is a gate where passenger came into the middle level of our station, and those passengers will go through the passenger control and luggage control, COVID control, and all those things which have to be done to go through those passengers before they go to the platforms. Next slide, please. Here you can see zoom out of our model of single station. Right now we are design the double station model, which allows us to exchange the transportation system between two cities. Those models is a station which allows our capsules go through. It's not the last station or the first, is the station which allows go through, and that's why from the left side is possible to drive by the capsule to the right side, and also from the right side it's possible to drive to the left side. Of course, the simplifications which you see here is the graphic, but our model have a lot of details. Please, next slide. Here you can see a little zoom of this. The middle floor, the middle level is the white one in the middle, and the below is visible the area where is the station, where are the platforms visible. Next slide, please. Oh, that's right. Here you can see the visualization, but also the simulation points where our capsule can stop to get the passengers. Of course, in our simulation, we can change the number of capsules, number of levels, number of platforms, number of passengers, a schedule table, etc., etc. That means it's full scalable model, which allows us to change any kind of factors we want to put to our model. Here there is an atmospheric pressure area. That means here the passenger came directly from the ticket office, for example, and they can go directly to their own capsule. Next slide, please. Here is another view from the passenger point of view, from the middle level, where you are right now in the gate to allows you to enter to this level. And after that, you can go down the stairs to our platforms. Please, next slide. Here's some slide which shows you the visualization. As you see, the passengers is during the on their way. Some of them are on the queue. Some of them are just to enter to the main gate. Of course, we can make a simulation to select how many security gates should be open, dedicated of the timetable of the capsules or of the time during the day, because the peak of the passenger flow can be in different time, at the morning or at the evening, but during the night the passenger flow is normal, it's lowest. Next slide, please. Here you can see our passengers goes through those stairs and goes to the selected chairs. You can see there are a lot of simplifications, as I mentioned, but the key is that we can redesign this model to achieve dedicated results of simulation. Please, next slide. Another zoom, as you see the simplification, for example, the shape of capsule is really simplified, because this model is huge. We want in future keep at least 5 stations like that. Each of those stations will be connected together. A lot of passengers will go through those stations. That's why if we import here dedicated graphics for our design of our capsule, the model will be really hard to run on a normal computer. Of course, we will take a part in the scalable computers, which allows us to do it, but then we will do it after we build full scalable model for example, 5 cities. Next slide, please. Here, as I mentioned, there is about the pressure and about the air. I will talk something about that. Here, the whole of this area is the normal air pressure. That means the passenger can go here and just enter or exit from capsule. Next slide. And here you can see the vision where the areas for the passenger are. You can see on the left side, the white area is dedicated passenger area. On the middle side, there is some areas where our trains or our capsules can change their platform and can change their tube. But these these intersections are right now in the air area still. And on the right side, you can see the double colors. There is a place where are our pressure chambers to keep during the using airlocks to reduce the pressure inside the tube. And the red one tubes on the right side, there is a empty tubes. There is a almost vacuum tubes there. Okay, next slide, please. Based on that, we prepare a simulation where we create a dedicated airlocks model and of course our intersections, which will be visible in next slide, please. Here you can see using those intersections, our idea was based on normal railways stations, because based on those simulations, we see the big scalable factor using the normal intersections, which was similar to railway technology, for example. Next slide, please. Based on this, you can see only the small part of our results, because right now some of results is not available to share you directly, because this is our IP. But we want to give you some opportunities to collaborate with us, because we are scientists. We want to share our knowledge. We want to take a part in some projects, and perhaps if you see opportunity to work together, we will be able to give you detailed information about our model. But of course, we will be able to build a model for other companies or other teams. It's a huge advantages when we can create a model which is full scalable model, and when we can receive from those model different data from statistical point of view, data from passenger flow, and etc. That gives us answers which kind of connection between two cities should be done to receive return of investments, for example. And this is a key question: to build or not to build Hyperloop in a selected direction. Next slide, please. Last but not the least, of course, we want to show our design also in real view. That's why we want to make in scale a 3D printer version of our station. And that's why we start preparing some tests, how to print some components to also keep it in a scalable way. And that's why we start cooperate with some students groups, which start to work. This group is Transpid AGH, and those groups start to work to design, build, and in the future to present the full scale of this station on the real. Next slide, please. And now, Dr. Gdowska, please show the final remarks of our presentation.
Okay, so now it is back to me. As you can probably sense from our presentation, we were in a perfect condition to design a station for non-existing technology and place it in a non-existing airport. So we were not limited by spatial constraints and other constraints. Only we were driven by economic calculus and availability of technological solutions. This is why we worked on digital twins of our station, and we have a huge experience in that, in designing using simulations of digital twins. And this is what we can share and collaborate in this area with other Hyperloop teams, because all we create a Hyperloop ecosystem in Europe and in the world. How can we sum up our presentation? As every station, our Hyperloop station in this huge hub should be as functional as possible, filled in with technological development, with accordance to so-called universal design, be available and accessible for all people, for all passengers who can have different disabilities. And all these elements make our station as functional and as user-friendly as possible. So here we are open for your questions, and we will be happy to answer them. If you would like to contact us with questions which could arise after our presentation, feel free to contact us by emails. And if you represent students groups, student scientific associations, you are invited to collaborate with our Transpeed AGH student group on Hyperloop projects. So thank you very much. And we are here to answer your questions.
Thank you so much for your presentation and all your insights, including the live animations. That was really very insightful and interesting. Thank you so much. We would like to head over to the questions, and I think you can leave your screen still shared as a background. So there are quite a lot of questions that came in. So I would like to start off with the first one. And so somebody's wondering, are you focusing on logistics or Hyperloop yourselves? Are you already working together with a Hyperloop partner, or do you source your info by yourselves?
Maybe this question, I will start at the beginning. Right now, we are, our group in general was created according to the Gospodstrategy project, which was previously Dr. Godowska talked about it. Those projects allows us to check a lot of different aspects of Hyperloop technology, the economical, the logistic, the technical aspects, and based on that, we have some conclusions which allows us to move forward with those research and try to connect those results to achieve some new quality of this area. That's why we are connected and focused not only on logistics. Right now, we show you only some part of our logistic studies. We are interested in a wide range of Hyperloop technology, from levitation till the different way of using, for example, wheels, but also about safety, security, engines, etc., etc. Our teams was divided by selected tasks. There was at least 7 main tasks, and those tasks was divided in some subtasks. It was really deep research according to this area. This is only the small part of our iceberg of our research in general, I can say.
All right, thank you very much. Then I would like to move to the next question. And somebody's asking, which technological concept, so which company have you taken as an example for your considerations and planning?
Maybe this is a little continuation of my previous answer, because we take at the beginning, we take consideration of very variety different Hyperloop concepts Just like similar, the previous presentation was done, we start from the 0 point. And right now, we develop some our own points to Hyperloop studies, which some our own technological issues. But for the logistic point of view, this model or these possibilities are very general. For example, we could build similar model for Hyperloop, Hyperloop 1, for example, or other companies based on data which will have to be provided to the selected model. That's why we are not strictly connected to any company, and that keep us, how to say, not connected. In that way, we are transparent, and that's why we are also focused to not promote solutions which is connected to any of company, but to search for solutions which will be the optimal for the technology, for the Hyperloop technology as general technology, not to promote those solutions because the company like us or other. No, we are searching for optimal solution in general. That's our aim right now.
That's very interesting. So the next question is a very interesting one. And yes, so somebody, or I think a lot of people are interested in knowing like the topic switches. So how far have you looked into switching concepts for Hyperloop tracks? So for instance, splitting of rails inside the Solidarity Hub.
About Solidarity Hub, perhaps Katarzyna could talk a little bit about the switching concepts. Just like I mentioned, we consider a very different way of Hyperloop technology. It could be rails, it could be wheels, it could be levitation systems. All together, we compare all those solutions together to achieve not only a solution which is viable, but which is economical. From economical point of view, it's good solution. That's the point. And we right now we don't promote any of those solutions because we see the advantages and disadvantages of each of them in general. Katarzyna, please continue.
Okay. I hope I understood the question, but why why we selected the Solidarity Transportation Hub? Because it is first the most possible location for Hyperloop station, and it is the most complicated one at the whole in the whole Hyperloop network in Poland, because this probably will be the place where more than one Hyperloop routes can meet. So there is also the problem of transfer. And the question was how intersection and switches of routes and rails there will be addressed. We adopted there some solution inspired by road intersections for highways, and all these connections will be underground, so we are not limited. We can always go deeper, so we are unlimited with intersections, because everything is done in the form of bypasses. I hope this is enough for now.
Yes, thank you very much for the explanation. So we have one last question, and it's a very specific one. So the question is, what will be the expected mean evacuation time of an average platform? Will it be less than 4 minutes? And also, and to the next point of safety, will it be less than 6 minutes? As per, and then it's named it's US NFPA 130, so a specific norm. Do you, yeah.
Perhaps one thing, in general, all norms which have to be done to design the platform, the station, Dr. Strychoniwska keep eye on those norms. And when we design something, we are strictly focused to connect those norms. I will just mention about the possibilities to validate the design using the flexing software. Using the flexing software, we are able to create those models, to put thousands of passengers there, and to create scenario with evacuation process. And if we don't achieve selected results which are connected to dedicated norms, we can rebuild it, change, update, and revalidate again. About the norms which was used till now, perhaps Dr. Strychoniwska could say some word about which norms we consider in our design. Dr. Strychoniwska, please.
Okay, for me, norm, this Europe norm and norm, Poland norm, and I say that this norm is important, and I use this norm, and so many norm. It is important, but now I don't see. I didn't see this norm. This norm we must create of Hyperloop, new norm.
Yeah, this is a good point. I want to just add something. Based on our research, we see a lot of standardization process is not suitable for Hyperloop technology yet. That's why the normal buildings norms or other things can be validated to standardization process. But some norms can be built from the scratch based on technology, rail technology or airplanes technology to suit to Hyperloop technology at all. That's why if there are some norms which we can use, we want to be strict. We want to use as much norms as possible to keep eye on the safety process. The safety and the security is the key to bring Hyperloop to the people, because there are a lot of norms will be developed in the future, or even during the process of working Hyperloop technology. We know it. That's why we built a roadmap for those process even. That's the point. We know we have to be very sophisticated to use any kind of norms we have in our knowledge, but also we have to make it a little wider than the normal process of normal project. It's unique to use some norms which is from a different area in general. Yeah, that's the point.
Okay, thank you very much for the explanations. And yes, for everything that you contributed today. I think due to time reasons, we would like to wrap it up. And so in the name of all the organizing parties, I would like again to say thank you to everybody who presented today, and also that you answered all our questions and gave a contribution to our seminar and to the platform that we want to establish and provide for that the exchange of Hyperloop can take place. So again, thank you very much, everyone. And yes, the next.
Excuse me.
Yes.
I would like to also invite and encourage all people who are involved in some Hyperloop technology and works together to perhaps send some message directly to our team, to us, because we would like to start cooperation with you, each of you in general. We want to share our knowledge, and we know in this step, single country in general, Hyperloop development technology is too weak. And that's why we want to join to some parties which are involved to this technology. And that's why we want to share our knowledge and share our experience. And perhaps we could help each other just to bring Hyperloop to our society. That's the point. And please feel free to send a message to us, and we will be able to join to some cooperation. Thank you.
Thank you very much. I think this is very good to know for everybody. So this also leads me to the next point to add here. So all the information, as a quick reminder, you can find on our website. It's vacuumtransport.org. So there you can, of course, also find the names and the topics of today. So as Rafael just said, if you would like to reach out to some of the speakers, please feel free to look for the names there. And I'm sure you can find everyone on either via Google or on LinkedIn. So yes, and as I just said, we have this website, vacuumtransport.org, and there you will also find the recordings of all the seminars. So feel free to watch today's seminar again or to find all the other seminars. Yes, exactly. And so the last point, our next seminar is already in a week on November 15th. So we would be very happy to welcome you all again and to take part in the next 2 interesting discussions and input talks. And yes, until then, we wish you a nice week and hopefully see you again next week. And have a nice evening, everyone. Goodbye, everyone.
Thank you. Bye.
Thank you very much.
Bye-bye.
Goodbye.
Thanks for presenting. Bye-bye.
Bye-bye. Thank you.
Bye-bye.